Welcome back everyone to the continuation of our discussion on the topic partial fraction. Today we'll be treating quadratic roots which cannot be factorized. Our very first question is from WAEC 2007. It states that express s plus 3 divided by s in bracket s squared plus 2 into partial fraction. Now a careful look at our denominator, we will realize that s squared plus 2 cannot be broken further or factorized further. So what we do is that, unlike the previous case where our denominator has no power, in this case we'll be equating it to a divided by s, that's the part without power, and bs plus c divided by the denominator with power. So in this case, s plus 3 divided by s in bracket s squared plus 2 will be equivalent to a divided by s plus bs plus c divided by s squared plus 2. So for our quadratic denominator that we can't factorize, when equating our partial fraction, the numerator of that part becomes bs plus c. From this point further, we solve as we've been solving partial fraction. So our next step is to multiply through by s in bracket s squared plus 2. And when we multiply through, we are left with s plus 3 is equals to a in bracket s squared plus 2 plus s in bracket bs plus c. Now we are going to be expanding our bracket, and after expanding to become s plus 3 is equals to as squared plus 2a plus bs squared plus cs. Next step, we are collecting like terms. So when we do that, it becomes s plus 3 is equals to as squared plus bs squared plus cs plus 2a. So at this point, we are going to be factoring out our common coefficient for our similar variables, and when we do that, it becomes s plus 3 is equals to a plus b in bracket s squared plus cs plus 2a. Now we are going to be comparing our coefficient on the left hand side and on the right hand side, and doing so we can see that a plus b will be equals to 0 because there is no coefficient of s squared on the left hand side. C will be equals to 1 because the coefficient of s on the left hand side is 1, and 2a, our constant, will be equals to 3. This will be our equation 1, equation 2, and equation 3, and we are going to be solving this simultaneously. So from equation 3, a will be equals to 3 divided by 2 because equation 3 is 2a is equals to 3, and dividing both sides by 2, a will be equals to 3 divided by 2. Now I'm going to be substituting the value of a to be equal to 3 divided by 2 in equation 1, and doing so 3 divided by 2 plus b will be equals to 0, and b will be equals to minus 3 over 2. Now having gotten the value of a, b, and c, now we're substituting for a, b, and c in the original expression. Doing so, it becomes s plus 3 divided by s in bracket s squared plus 2 will be equals to 3 over 2 divided by s plus minus 3 over 2 in bracket s plus 1 divided by s squared plus 2. And we are going to be simplifying our right hand side further, which we accomplish by first of all solving the fraction in our numerator. So doing so, it becomes s plus 3 divided by s in bracket s squared plus 2 is equals to 3 divided by 2s plus minus 3s plus 2 divided by 2 divided by s squared plus 2. Simplifying further, it becomes s plus 3 divided by s in bracket s squared plus 2 is equals to 3 divided by 2s plus in bracket minus 3s plus 2 divided by 2 in bracket s squared plus 2. We can also simplify our right hand further, and our final solution would be s plus 3 divided by s in bracket s squared plus 2 is equals to 3 divided by 2s plus 2 minus 3s divided by 2 in bracket s squared plus 2. We simply modified our numerator by taking the negative part and bring it after the positive part in the right hand side, and our final answer is A. Our next question is from NECO 2005. It states that resolve 3 divided by s minus 1 in bracket s square minus 5s plus 2 in bracket into partial fraction. Now our denominator s square minus 5s plus 2 cannot be factorized further, so we'll be saying let 3 divided by s minus 1 in bracket s square minus 5s plus 2 in bracket be equivalent to a divided by s minus 1 plus bs plus c divided by s square minus 5s plus 2. So at this point we'll be multiplying through by s minus 1 in bracket s square minus 5s plus 2 in bracket. After multiplying through, it becomes 3 is equals to a in bracket s square minus 5s plus 2 plus bs plus c in bracket s minus 1 in bracket. Our next step is to expand our bracket, and after expanding it becomes 3 is equals to as square minus 5as plus 2a plus bs square minus bs plus cs minus c. The next step is to collect like terms, and when we do that, 3 will be equals to as square plus bs square minus 5as minus bs plus cs plus 2a minus c. Now we are going to be factoring out our coefficient, and when we do that, 3 will be equals to a plus b in bracket s square minus in bracket 5a plus b minus c s plus 2a minus c. At this point we are going to be comparing our coefficient on the left hand side and on the right hand side. For s square, a plus b will be equals to 0 because there is no coefficient of s square on the left hand side, and minus 5a minus b plus c will be equals to 0 because there is also no coefficient of s on the left hand side, and our constant 2a minus c will be equals to 3. Now this we are going to be solving simultaneously. Doing so, for equation 1, b will be equals to minus a. Let's call this our equation 4. And also from equation 3, 2a is equals to c plus 3 and c will be equals to 2a minus 3. Let's call this our equation 5. Now substitute c equals to 2a minus 3 and b equals to minus a in equation 2, and when we do this, equation 2 becomes minus 5a minus in bracket minus a plus in bracket 2a plus 3 is equals to 0. Expanding our brackets, it becomes minus 5a plus a plus 2a minus 3 is equals to 0. Simplifying, it becomes minus 2a minus 3 is equals to 0. Therefore 2a will be equals to minus 3, and dividing both sides by 2, a will be equals to minus 3 over 2. Our next step is to substitute a is equals to minus 3 over 2 in equation 1, and when we do that, it becomes minus 3 over 2 plus b is equals to 0, and b will be equals to 3 over 2. Now we are going to be substituting a equals to minus 3 over 2 in equation 5. Doing so, c will be equals to 2 in bracket minus 3 over 2 minus 3. Simplifying, it becomes c is equals to minus 3 minus 3, which is equals to minus 6. Now having got to the value for a, b and c, we are going to be substituting a, b and c in our original expression, and doing so, it becomes 3 divided by s plus 1 in bracket s squared minus 5s plus 2 in bracket will be equals to minus 3 over 2 divided by s minus 1 plus 3 over 2s minus 6 divided by s squared minus 5s plus 2. We are going to be simplifying our right hand side by simplifying the fractions. Doing so, it becomes minus 3 divided by 2 in bracket s minus 1, and simplifying our numerator, it becomes 3s minus 12 divided by 2 divided by s squared minus 5s plus 2. Simplifying further, it will be equals to minus 3 divided by 2 in bracket s minus 1 plus 3s minus 12 divided by 2 in bracket s squared minus 5s plus 2. Now rearranging our answer by bringing the negative part afterwards, it becomes 3s minus 12 divided by 2 in bracket s squared minus 5s plus 2 minus 3 divided by 2 in bracket s minus 1. Our next question is from NECO 2012. It states that express 1 divided by s cubed minus 1 into partial fraction. Now the very first step is to factorize our denominator, and when we do that, factorizing s cubed minus 1, it will be equals to s minus 1 in bracket s squared plus s plus 1 in bracket. And as you can see, s squared plus s plus 1 cannot be factorized further. So 1 divided by s cubed minus 1 is equals to 1 divided by s minus 1 in bracket s squared plus s plus 1 in bracket. So we are going to be saying let 1 divided by s minus 1 in bracket s squared plus s plus 1 in bracket be equivalent to a divided by s minus 1 plus bs plus c divided by s squared plus s plus 1. Our next step is to multiply through by our denominator s minus 1 in bracket s squared plus s plus 1 in bracket. And when we multiply through, it becomes 1 is equals to a in bracket s squared plus s plus 1 plus bs plus c in bracket s minus 1 in bracket. Our next step is to expand our bracket, and after expanding we are left with 1 is equals to as squared plus as plus a plus bs squared minus bs plus cs minus c. The next step is to collect like terms, and when we do that, 1 will be equals to as squared plus bs squared plus as minus bs plus cs plus a minus c. We are going to be factoring out at this junction, and when we factor out, it becomes 1 is equals to a plus b in bracket s squared plus a minus b plus c in bracket s plus a minus c. And comparing our coefficient on the left and on the right hand side, we can see that a plus b is equals to 0, a plus b plus c is equals to 0, and a minus 1 and a minus c rather is equals to 1. This is going to be our equation 1, equation 2, and equation 3, and we are going to be solving simultaneously. Now solving simultaneously, from equation 1, b will be equals to minus a. So we are going to be substituting b is equals to minus a in equation 2, and doing so, equation 2 becomes a minus in bracket minus a plus c is equals to 0, which simplifies to 2a plus c is equals to 0. This will be our equation 4. Now from equation 3, a is equals to c plus 1. So substitute a equals to c plus 1 in equation 4, and when we do this, equation 4 becomes 2 in bracket c plus 1 plus c is equals to 0. Expanding the bracket, it becomes 2c plus 2 plus c is equals to 0, which will become 3c plus 2 is equals to 0, and 3c will be equals to minus 2, and dividing both sides by 3, c will be equals to minus 2 divided by 3. At this point, we are going to substitute c is equals to minus 2 divided by 3 in equation 3, and when we do that, equation 3 becomes a minus in bracket minus 2 divided by 3 is equals to 1. Opening our bracket, it becomes a plus 2 divided by 3 is equals to 1, because the negative times negative will become positive, and a will be equals to 1 minus 2 over 3, which is equals to 1 over 3. Now we are going to substitute a is equals to 1 over 3 in equation 1, and doing so, equation 1 becomes 1 over 3 plus b equals to 0, and b will be equals to minus 1 over 3. At this juncture, we are going to substitute for a, b, and c in the original expression, and when we do that, it becomes 1 divided by s minus 1 in bracket s squared plus s plus 1 in bracket will be equals to 1 divided by 3 divided by s minus 1 plus minus 1 over 3s minus 2 over 3 divided by s squared plus s plus 1. Simplifying the fractions on our right hand side, it will be equals to 1 divided by 3 in bracket s minus 1 plus minus s minus 2 divided by 3 divided by s squared plus s plus 1. Simplifying further, it will be equals to 1 divided by 3 in bracket s minus 1 minus s plus 2 divided by 3 in bracket s squared plus s plus 1. Our next question states that resolve s squared plus 4s plus 1 divided by s cubed plus 3s squared plus 4s plus 2 into partial fraction. Now our very first step is to factorize our denominator, and factorizing the denominator, s cubed plus 3s squared plus 4s plus 2 is equals to s plus 1 in bracket s squared plus 2s plus 2 in bracket. So therefore s squared plus 4s plus 1 divided by s cubed plus 3s squared plus 4s plus 2 is equal or similar to s squared plus 4s plus 2 divided by s plus 1 in bracket s squared plus 2s plus 2 in bracket. And by expression, s squared plus 2s plus 2 cannot be factorized further. So we are going to be saying let s squared plus 4s plus 1 divided by s cubed plus 3s squared plus 4s plus 2 be equivalent to a divided by s plus 1 plus bs plus c divided by s squared plus 2s plus 2. At this point, we are going to be multiplying through by s plus 1 in bracket s squared plus 2s plus 2 in bracket, and doing so it becomes s squared plus 4s plus 1 is equals to a in bracket s squared plus 2s plus 2 plus bs plus c in bracket s plus 1 in bracket. Our very next step is to expand our bracket, and expanding bracket it becomes s squared plus 4s plus 1 is equals to as squared plus 2as plus 2a plus bs squared plus bs plus cs plus c. Now we are going to be collecting like terms, and collecting like terms it become s squared plus 4s plus 1 is equals to as squared plus bs squared plus 2as plus bs plus cs plus 2a plus c. Now at this junction we will be factoring out, and when we factor out it becomes s squared plus 4s plus 1 is equals to in brackets a plus b s squared plus 2a plus b plus c in bracket s plus 2a plus c. Now comparing coefficients, we can see that a plus b will be equals to 1, 2a plus b plus c will be equals to 4, and 2a plus c will be equals to 1. This is going to be our equation 1, 2 and 3, and we'll be solving simultaneously. From equation 1, b will be equals to 1 minus a, and we're going to be making this equation 4. And from equation 3, c will be equals to 1 minus 2a. Now substitute b is equals to 1 minus a and c is equals to 1 minus 2a in equation 2. Equation 2 becomes 2a plus in bracket 1 minus a plus in bracket 1 minus 2a is equals to 4. And opening our bracket, it becomes 2a plus 1 minus a plus 1 minus 2a is equals to 4. And rearranging further, it becomes 2a minus 2a plus 1 is equals to 4, which becomes minus a plus 2 is equals to 4, and minus a will be equals to 4 minus 2, minus a will be equals to 2, or a is equals to minus 2. Now substitute a equals to minus 2 in equation 1. Equation 1 becomes minus 2 plus b is equals to 1, and b will be equals to 2 plus 1, which is equals to 3. Also substituting a equals to minus 2 in equation 3. Equation 3 becomes 2 in bracket minus 2 plus c is equals to 1, and opening our bracket it becomes minus 4 plus c is equals to 1, and c will be equals to 1 plus 4, which is equals to 5. Now we are going to be substituting for a, b and c in the original expression, and when we do that, s squared plus 4s plus 1 divided by s cubed plus 3s squared plus 4s plus 2 will be equals to minus 2 divided by s plus 1 plus 3s plus 5 divided by s squared plus 2s plus 2. We can also rearrange our right hand side to become 3s plus 5 divided by s squared plus 2s plus 2 minus 2 divided by s plus 1. We have another question from WAEC that states that resolve 7 minus s divided by s plus 1 in bracket s squared plus 1 into partial fraction. So as usual, we are going to be saying let 7 minus s divided by s plus 1 in bracket s squared plus 1 be equivalent to a divided by s plus 1 plus bs plus c divided by s squared plus 1. Now next step is to multiply through by s plus 1 in bracket s squared plus 1, and after multiplying through it becomes 7 minus s is equals to a in bracket s squared plus 1 plus bs plus c in bracket s plus 1 in bracket. Now we are going to expand our bracket, and when we expand our bracket it becomes 7 minus s is equals to as squared plus a plus bs squared plus bs plus cs plus c. At this point we are going to be collecting like terms. Collecting like terms is becomes 7 minus s is equals to as squared plus bs squared plus bs plus cs plus a plus c. At this point we are going to be factoring out. Factoring out, it becomes 7 minus s is equals to a plus b in bracket s squared plus b plus cs plus a plus c. Now we are going to be comparing our coefficients. Comparing coefficients, we realize that a plus b is equals to 0, this will be our equation 1. B plus c is equals to minus 1, this will be our equation 2. And a plus c is equals to 7, this will be our equation 3. And we are going to be solving this equation simultaneously. Solving simultaneously, from equation 1, b is equals to minus a. Now we are going to be substituting b equals to minus a in equation 2. Doing so, equation 2 becomes minus a plus c is equals to minus 1. It's going to be our equation 4. From equation 4, c is equals to a minus 1. Now we are going to substitute c equals to a minus 1 in equation 3. And when we do that, equation 3 becomes a plus in bracket a minus 1 will be equals to 7. And opening our bracket becomes a plus a minus 1 will be equals to 7, which is 2a is equals to 8. And dividing both sides by 2, a will be equals to 4. Now our next step is to substitute a equals to 4 in equation 1. Substitute a equals to 4 in equation 1. Equation 1 becomes 4 plus b is equals to 0, and b will be equals to minus 4. Next, we substitute a equals to 4 in equation 3. And when we do that, equation 3 becomes 4 plus c is equals to 7, and c will be equals to 7 minus 4, which makes c to be equals to 3. Now substitute for a, b and c in the original expression. It becomes 7 minus s divided by s plus 1 in bracket s squared plus 1 in bracket will be equals to 4 divided by s plus 1 plus minus 4s plus 3 divided by s squared plus 1. Simplifying our right hand side further, it becomes 4 divided by s plus 1 plus 3 minus 4s divided by s squared plus 1. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can easily get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website at the bottom of the screen. Thank you.